Good morning, Algebra 2. We're going to be covering lesson 57, which is on exponential growth and decay. So a little review. This is how an exponential equation looks. Notice your exponent is x. So it makes it exponential. The exponent is x. Now there are two kinds, growth or decay. Growth is something obviously that's growing over time, but this is when your base is greater than 1. So, for example, it'd be if it's 1.5 or 8 or 20. Decay is if your base is less than 1, but it's greater than 0, meaning it's not negative. So, example, 0.25, 0.8, 1/3. Okay, so these are bases that are less than 1. So that is the first part of our lesson practice, and we'll get to it in a second. The next is a review on compound interest. So, sorry, this should say y. There are two formulas to calculate interest, and one is used if it says compounded yearly, quarterly, this should say monthly, daily, etc. If it mentions those words, then I know that I need to use the amount in our account is P times 1 plus our rate divided by N to the N times T. Okay, so that's if the following words are used, if it says compounded yearly, quarterly, monthly, daily, etc. If our interest is compounded continuously, meaning the bank is calculating, probably a computer, is calculating it all the time, continuously, every second, then we would use the amount in our account equals the principal that was deposited times E to the R times T. So notice the difference in these formulas, and they will determine when we use which one is based on the wording. So we're going to jump into our lesson practice on page 409, part A. So part A, a savings account had an annual interest rate of, so the rate was 3.5%. Compounded, says compounded monthly. If the account begins with a principal balance of $5,000, what will its value be after 4 years? So this is the information that is important out of this. And so I'm going to label the pieces. We need to make R a decimal, so 0.035. So that's R. Okay, I know it, but I'll go ahead and put that. Compounded monthly, this represents N, and there are 12 months in a year, so N equals 12. This, it told you that principal, or the amount you initially started with, is $5,000, and 4 years represents time. So I'm going to plug that into my formula. A equals my principal times 1 plus my rate over N to the N times T, or you can write T first, it doesn't matter. But I am going to enter this exactly as it appears into my calculator. So 5,000, let me turn it on, sorry, 5,000, parentheses 1 plus 0.035 divided by 12, close out my parentheses. The only thing I need to add is my calculator requires this exponent button. And then instead of me putting parentheses, I'm going to go ahead and simplify that. 12 times 4 is 48. And so I get a total of 5,750. And I'm going to round 19 cents, would round that to 20 cents. So that is how much would be in my account after 4 years, meaning I earned about $750 in interest. So part B. The part B is all the same information. The difference is it says compounded continuously. So it's the same information above, but I'm going to be using the formula A equals P times E to the R times T. So I have 5,000, same amount, times E, but in my parentheses is my rate times 4. So I'm going to show you how to enter that in my calculator, 5,000. I have to shift and hit the button that has the E above it. And notice it automatically gives me the exponent button. So 0.035 times 4. And I'm going to close those parentheses out so I have a nice set. And I get 57, 51, and 37 cents. So it's not a lot more, but it is slightly more than the one above because it's being compounded continuously. Now, the more money you put in, the bigger difference this is going to demonstrate. Now, part C. This says after 4 years, it's being compounded continuously at 4%, and it has a worth, a total, of 15,320. And it's asking to find P, the amount that was initially deposited. So 4 years, right? That's T. Continuously means I'm going to use A equals P, ERT. 4%, that means our rate is 0.04. Total, that would mean what A is, and we're looking for P. So I'm going to go ahead and set it up. It says I'm going to have a total or a balance of 15,320. It's asking for how much I deposited times E, and then my rate, 0.04 times 4 years. So I'm going to simplify. I'm going to enter this in my calculator. Okay? So second E, 0.04 times 4, because E has a numerical value. So I got 1.735. So I now have 15,320 equals 1.1735 times P. Now to solve for P, I'm going to divide by that decimal to get P all alone. So 15,320 divided by 1.1735, and I get that I must have originally deposited 13,000, and I think it says around. It doesn't tell me what to round to, but I'm going to. It says 13,055. And so that's how much was deposited. So moving on to part D. I'm going to move that up a little bit. All right, so a mass carbon decays in such a way that it will disappear after 5730. So after 5,730 years, I will have 0 left. So I set that up as X, Y. And let me fix that. And then it also says that it says that what portion of 10 kilogram mass of atoms will remain after 9,000 years. Oh, sorry. This says that in this many years, half will appear. And it's wanting to know in 9,000 years how much will remain. So here is how I'm going to set it up. I know that when y is, I'm going to put, instead of 1/2, 0.5. I don't know what my base is, and I actually don't know what A is. I had 5730. And so that is what I have so far. Okay. So in order to figure out what is left, I have to actually, and this makes it super hard to rewrite this, I'm going to actually have to take the 5730 root of, or 0.5, sorry, to the 1/5730 to equal, and let me do that real quick. 0.5 to the 1, whoops, parentheses 1 divided by 5730. 0.9. I set this up wrong. Sorry, guys. And my computer's timing out. Hold on. Let me unlock my computer. I should probably fix that setting on my computer, but I haven't. All right. Sorry. So this is saying 1/2 equal to an A times B to the 5730. And I have to solve for B. So the only way to do that is to, and I don't know what A is to then take to solve this. So I would say 0.5. Now the only way to solve this is do 1 over 5730. And then to raise that to the 9,000th power because that is x. So I am then going to raise this to the 9,000 power. Don't worry, you will not get one this difficult. And I get 0.34. So 0.34 times 10 would leave me with 3.4 kilograms. Now, you will not be given one that difficult, but we are going to move on to E. Now, E gives us a table, and it wants us to complete it. And so I'm going to copy the table down really quick. I have x is 0, 10, 15, 45. When x is 0, y is 803, 412. It wants me to find the y value for these two. So I'm going to rewrite this. When x is 0, y is 803. When x is 10, y is 412. So y equals a times b to the x. I'm going to plug in the first set of points. So when y is 803, I don't know what a is, times b to the 0th power. So I'm plugging in, this is x, this is y. Now anything to the 0th power is 1. So I now know that a equals 803. So now I'm going to plug in the second pair of points. So 412 equals 803 times b to the 412. Whoops, to the 10th. Sorry. So notice I plugged in, and I meant to color code that. I am a mess right now. There. So I solved for A. Now I'm going to solve for B. So I would divide both by 803. I'm going to rewrite it over here. 412 divided by 803, I got 0.51 equals b to the 10th. Now, to get rid of to the 10th, I can raise each side to the reciprocal. And so I'm going to simplify the front, and I get 0.93 equals a b. So now I have an equation I can use. I found A, and I have found B. So I can now plug in 15 for x and find y, and 45 for x and find y. So y equals 803 times 0.93 to the 15th. This first one, so 803 parentheses 0.93 to the 15th, and I got 270.4. Now I'm going to use the arrow up, and I'm going to change this to 45, and y is now 30.7. And so we just found those last two numbers. All right, part F says the population in Phoenix was in 1990, so we're going to count 1990 as year 0. So in the 0th year, I'm beginning with 983,403. Then it says in 2000, which is exactly 10 years later, I have 1,321,045. And it's asking us to predict the population in 2010, which since 1990, that's year 20. So it's asking for what's the population in 20 years. So first I'm going to find my equation by plugging in my first pair, right? 983,403 is y equals a times b to the 0. So I plugged in x and I plugged in y. B to the 0 is 1, so a equals 983,403. Now I'm going to plug in the second pair, so 1,321,045 equals a times b to the 10th. So now I plugged in this x and this y. So to solve, right, I'm dividing both sides by the 983,403. And I have b to the 10th equals, I got a decimal of, where did I put it? Let me enter it. 1,321,045 divided by 983,403. And I got 1.343. And then I'm going to raise, to get rid of the 10th, I have to raise each side to the 1/10. So 1.343 to the 1 divided by 10. And I got b equals 1.03. So now I've solved for a and I've solved for b. So now I can solve for y. So y equals my a times b, and it's saying in 20 years. So I'm going to enter that, 983,403 times 1.03 to the 20th. And I get 1,776,130. So I have, there are 1,776,100. It is talking about population, so I can't have a decimal for people. And that is the end of that. For homework, we will skip numbers 6, 7, 19, 20, 23, 25, and 26. Thank you.